Welcome to the first video of this course about photovoltaic systems. In this introduction section, you will learn all about different kinds of PV systems and you will get familiar with all the components used in a PV system. Before we dive into the PV systems, however, let's first understand how the electricity network delivers the power from the suppliers to the consumers and how renewable energy can be integrated in such a network. Nowadays, we are facing a change in the paradigm of how energy is delivered from a power plant to the loads. Until now, the used electricity network can be defined as a centralized and monodirectional distribution system. At the one hand of the electricity grid, we have the power plants, which are the only structures generating electricity. They can be divided into three major groups. First, the thermal power plants. These plants generally burn gas or coal and to boil water to superheated steam, which in turn runs to a turbine. The second group are the nuclear power plants, which use the heat released by the fission of radioactive elements to generate electricity. Finally, there are the hydroelectric power plants, where the kinetic energy of falling water drives turbines, generating electrical power. Electricity is generated at an extra high voltage of around the 400 kilovolts, and the power of each plant ranges from tens of megawatts to some hundreds. Generally, these plants are located several kilometers away from the cities or the load centers because they require a huge amount of land and water. For this reason, the power has to be transmitted efficiently over long distances. The transmission line accomplishes this task. The electricity is transmitted in tri-phase alternating current as proposed by Nikola Tesla. The voltage is still very high, between 50 and 150 kilovolts. This is important since the power dissipation depends on the current flow squared. Therefore, at high voltage and the low current, the power dissipation by the cables is minimal. Before arriving at the socket of an house or factory, the voltage must be further decreased to less than 10,000 volts. This is performed in a substation, which has the role to switch control and protect the electrical circuits. Then, from this substation, the power is supplied at different voltage levels to the loads. The loads are, in this case, the houses, factories, or utilities in a city. To arrive at an house, the power has to be distributed through the city network. This might be achieved by means of utility poles. So now we have electricity at a voltage level of 220 volts in the house sockets. As you may notice, the power flows only from the left to the right. Furthermore, the voltage gradually decreases as the distance from the production plants increases. That is because the transmitted power also decreases closer to a specific load. So, the configuration of this electricity grid is centralized and monodirectional because the power plants are the roots of this network. Only the plants generate power, and the power flows exclusively from the plants to the utilities in only one direction. Now, let's start to move towards a more advanced network that can integrate renewable energy sources. The arguments in favor of a renewable energy transition are many, but the two main ones are regarding environmental concerns, such as climate change. The second main reason is that renewables, such as solar and wind energy, are becoming cost-effective due to research investment and the large-scale implementation of these technologies. We therefore need to rethink our transmission system. It has to be adapted to properly integrate renewable energies, which, unlike the conventional power sources, can be produced on-site. As a consequence, the system is decentralized and has to account for the uncontrollable nature of the renewables. In this way, we need different types of storage for day and night variation, but also for the seasonal variation. A little bit of statistics. In this slide, you can see the installed power generation capacity in Europe. Until 2011, renewable energy sources, or RES, were steadily increasing. In this respect, PV systems have clearly gained a large share in these numbers. In just 10 years, the PV power capacity in Europe steadily increased from a few megawatt in 2000 to more than 20 gigawatt in 2011. The other renewable energy sources, such as biomass, hydro, geothermal, and oceanic, have also been increasing their installed capacity over the past decade, albeit more slowly than wind and solar PV. Europe's power generation capacity continues to move away from fuel oil, coal, nuclear, and gas to a higher share of renewables. Since 2013, gas decommissioned more megawatt than what it installed, but still has the most overall installed capacity. From 2011 onwards, the growth of yearly installed PV capacity decreased and reached a constant share of 30% of the total. So let's look at solar energy. The sun provides a huge amount of energy, which is more than sufficient to satisfy the actual global human consumption. Moreover, there are big advantages in using PV systems. First, the PV systems are silent since there are no moving parts in contrast to other power plants. Solar energy is emission-free, requires low maintenance, especially compared to a classical coal-fired plant. More importantly, solar energy is generated decentralized. That is, it can be used and generated in the same place. So when we think about new ways how to look at the power distribution system, solar energy plays a key role in the energy mix. But how exactly are renewable energies integrated in the classical electricity network that we saw earlier? Solar and wind farms can be introduced in the system, generating several megawatts of power. These farms are located several kilometers away from the loads, just like the normal power plants. Therefore, they require high voltage transport along the classical transmission line. Apart from traditional AC three-phase power transmission, high voltage direct current systems may be used for long distances, such as an offshore wind farm. These power transmission systems may be less expensive and exhibit lower electrical losses. Small PV systems can also be implemented on the rooftops of buildings. This changes the characteristics of the electricity network, since now the energy generated must be able to flow back to the switchgear and be redirected to other loads. We already cited the importance of storage, which should balance the mismatch between renewable power generation and consumption. Storage units can be placed in the substations or simply in the buildings. To recap, the grid of the future has to be smart in order to efficiently combine different and unpredictable power sources. The electricity flow is bidirectional and decentralized depending on the availability of the sun and of the wind. On very big voltage scale, we can also have a bidirectional distribution with solar power plants or wind farms. It is therefore important to realize that renewable sources enable the production of power exactly where it is needed.